evaluate limit extends to positive infinity sine 1 over x divided by r tan 1 over x. Okay, in this function, here we have 1 over x, here we have 1 over x. Instead of 1 over x, if I have just one variable, it will become a simpler function. I think I can evaluate the limit easily. So I'm going to assign a new variable y for this 1 over x. So let y equals to 1 over x. Actually, we have the given limit in the variable x, but I'm changing it to the new variable y. Okay, in limit problem, whenever I change the original variable to some other new variable, I have to change the limit also to the new variable. Okay, here the limit of the original variable x is positive infinity. But now I need the limit for the new variable y. If x approaches positive infinity, y approaches what? Already we know that y equals to 1 over x. Then y tends to 1 over this x has to be replaced by its limit, that is positive infinity. Okay, here I divide a finite value 1 by a very large positive value. Whenever I divide a finite value by a very large positive value, it is equal to 0. So if x approaches positive infinity, y approaches 0. Okay, now let's change the complete problem to the new variable y. So limit, instead of taking x tends to positive infinity, we can take y tends to 0. Sine, instead of this 1 over x, we can take y and r tan y. Okay, now let's substitute the given, let's substitute the limit for y. That is, the limit for y is 0. So it's going to be sine 0 over r tan 0. Okay, we know that the value of sine 0 is 0, but we are not sure what's the value of r tan 0. Okay, already we know that r tan is nothing but tan inverse. R tan 0 means it's nothing but tan inverse of 0. Okay, now I need the value of tan inverse of 0. So that is equal to r tan 0. Okay, I assume the value of tan inverse of 0 is theta. That is theta equals to tan inverse of 0. Okay, now I move this tan inverse to the left side. When I move this tan inverse to the left side, it will just become tan, and already we have theta. So we get tan theta equals to 0. Okay, here we have to get the value of theta. Theta is an angle measure. For what angle measure of theta, the value of tan is 0. So it's very clear, that is tan 0 is equal to 0. So it's now we got the value of theta. So theta is 0. If theta equals to 0, then tan inverse of 0 is equal to 0. Because theta and tan inverse of 0 are equal. So since theta is equal to 0, the value of tan inverse of 0 is also 0. And tan inverse of 0 is nothing but r tan 0. So finally we got the value of r tan 0, that is 0. So 0 over, instead of this r tan 0, we can write 0 because 0 is its value. So here we get the result of the limit as 0 over 0, which is called indeterminate form. Okay, so whenever we get indeterminate form like 0 over 0 as a result in evaluating a limit, we have to use L'Hopital's rule because this is not the final answer. So whenever we get indeterminate form 0 over 0, it cannot be considered as a final answer. So we can evaluate the given limit using L'Hopital's rule. Okay, if I want to use L'Hopital rule, I just have to take the step which is right before where I have applied the limit. So this is the step I have applied the limit, that is y tends to 0. Now you just take the step which is right before that. That is limit y tends to 0 sine y over r tan y. Now in this step, I'm going to apply L'Hopital's rule. Okay, let's continue this on the next page. Okay, now let's use L'Hopital's rule. So this is a step I'm going to use L'Hopital rule. L'Hopital rule means what we need is we have to find the derivative of the numerator and denominator with respect to the variable for which we have the limit. So here we have limit for the variable y. So now I have to find the derivative of the numerator and denominator separately with respect to the variable y. Okay, so in finding derivative, whenever we find variable y in numerator and denominator, usually we'll be using coefficient rule. But when you use L'Hopital rule, you are not supposed to use coefficient rule. Okay, now I'm just taking this step. I'm going to find the derivative of this sine y and r tan y with respect to the variable y because we have limit for the variable y. So limit y tends to 0. So if I find the derivative of this sine y with respect to y, it will be cosine y. And if I find the derivative of r tan y, that is 1 over 1 positive y square. Okay, so here now I can apply the limit for y, that is 0. So then I'll be getting cosine 0 over 1 over 1 plus 0 square. We know that the value of cosine 0 is just 1 and 1 over, so the value of 1 plus 0 square is just 1 over 1. So we get 1 over, the simplification of this 1 over 1 is 1. Finally, 1 over 1 is 1. So I just evaluated the given limit. So the result of the given limit is just 1.